Assalamualaikum warahmatullahi wabarakatuh and good day again. So let's continue a little bit more on the theory part for the lateral earth pressure. So just now we already seen for the at rest condition and also active and passive in cohesion and also cohesionless soil for the Rankine method. Okay, so similarly goes for the Coulomb theory. And in fact, this Coulomb theory is already here, a century earlier compared to Rankine. And please note that Rankine always assume smooth interaction between the retaining wall to the soil interaction, smooth condition one. But Coulomb's consider for the friction that occurs between the soil and also the structure. So we could say that Coulomb theory is much more details, consider much more effect, and the pressure produced from Coulomb can be more smaller compared to Rankine. Okay, due to the friction angle, friction between the wall and also soil. Okay, so in my slide, I only shows one condition of the Coulomb's theory, regardless the soil types. But actually, you can go to this video by Professor Kitch. I think Professor Kitch. We can see a lot of conditions similarly for cohesive soil and cohesionless soil for Coulomb, and with the soil at the back is a flat condition or having a inclined slope like this one. So in my slide, I only focus for this condition for teaching and learning only. For more, you can explore and you can also study the video by Professor Kish to know more. Okay, in previous, the angle of the back slope, the angle of inclination of soil at the back slope is known as a beta. But now we use for alpha, follow the Dr. Kamaruddin's module text if you have one. So alpha here, delta with the, oh I forgot to adding, this is pressure. The blue arrow is a pressure that exerted to the pressure that produced by soil to the retaining wall, exert to the retaining wall. And the soil itself have a gamma properties, unit weight, and also angle of friction. And at some condition, the failure line is lay at the angle of theta, and the retaining wall angle also have some beta angle. Okay, so that the Ka can be addressed like this, and Kp is inverse of Ka, and pressure of active similarly can be defined as simple as Rankine just now. Okay, so what we can do from knowing the lateral earth pressure, we can design the retaining wall, or in our course we try to design the gravity wall. But this info is actually much more associated with the structure subject. So we just focus things that the soil affect to the retaining wall, not to design the retaining wall itself. But when we knowing how much the pressure, we can suggest the design of retaining wall. So once we know the pressure, we can continue to check for overturning of the wall, the sliding of the along the base, and also the bearing capacity failure. So this is how some of the guidelines to check for overturning. We knowing the moment of resistance to moment of overturning, and we know the sliding forces, horizontal that resist, and also that driving the force. So we can calculate as long as we understand how to get the pressure active and passive. So here is active pressure, passive pressure. So we have to obtain that first, then after that we can calculate the forces. Similarly, for the bearing capacity failure, as long as we know the active pressure and also the passive pressure, so we can check the loading, range of maximum to minimum, vertical stress, eccentricity if we have one, and with the width of the design wall B width, so we can have a moment of retaining minus moment of overturn through divided by the vertical. So after this chapter, I will give you a group project to solve a engineering problem. So later for this one, we can divide into, I think, 3 to 4% per group, as we do in the previous activity. And the deadline of the project is usually at the end of the semester. Okay, so in this slide also, I attach some of the activity you can done by yourself. So actually sketch the three diagram of the lateral earth pressure condition. So at rest, active and passive, how you want to sketch. And what the K value or the P value, P sub P or P sub A or K naught and so on. So this usually we ask during the test or during the final exam. In final exam, usually sketching each condition itself and describe something can get you about 6 to 9 marks. Okay. So in the slide also I put the lateral pressure at rest exercise, so you can try to solve. Let's say this is exercise, so you have a sand silk with a phi angle friction angle, soil friction angle, you know the gamma. So and it is a C equal to 0, so it means cohesionless soil, granular soil maybe. So you can define the P for A, pressure for B, pressure for C, pressure for water. So you can have a lateral earth pressure A plus B plus C, can have a pressure water, and total horizontal pressure is all P naught plus PW. For active and passive pressure, so you can also go through the exercise. This is some of the solution. First, calculate the K sub A first. And then once you know the Ka, you can start to calculate the pressure of A, B, C, and D. So you can have a solution. Similarly, you can try for the slope, for the soil with the inclined slope. So you have to define first beta here. So what is beta? So maybe tangent, tangent 1 over 3. So you can have a beta. So after that, you can substitute beta into A, and knowing the internal friction angle, so you can have a pressure. So it is actually quite straightforward, except for the beta. You have to define the beta first. Okay, for exercise 3, you can try to calculate both pressure at active and pressure at passive. So now it is cohesive soil over here, but it is a cohesionless soil. So let's say you can use Rankins method. So how to define, how to solve the problems, and is it safe or not? Does the sand field sufficient to retain the movement of the wall? Is it safe or not? Okay, so last but not least, the exercise for Coulomb's theory. So knowing that the internal friction angle is delta, internal friction angle is there, okay. Oh no, interface friction angle, okay. The friction between the soil and retaining wall is delta equal to 2/3 of friction angle. Okay, so then you can use the K sub A active, so you can solve the to get the pressure of active pressure, I think. So I think that's all for the lateral earth pressure. Uh, Later on we can see you in online. So assalamualaikum warahmatullahi wabarakatuh. Bye.